Good evening, all. Good evening.
Good evening, sir.
Yes, good evening, all. What we were going with the last class? Guys, what we were going in the last class? Are you here? In the yesterday's class, what we learned? Children, can you hear me or not? So we were going with a question. So we'll go with this question today. Yes, everyone solve this question. Everyone solve this question quick. See the total number of matrices A is equal to given to you x comma y belongs to real numbers and x should not be equal to y, for which A transpose into A is equal to 3I3 is dash. Look at this here. So total number of matrices from this x comma y belongs to R and x is not equal to y. Okay, and for which A transpose into A is equal to 3I3 given to you. Correct? Yes. Now here, one second, guys. I think I should hold. Yeah. Yes. A matrix. What is the matrix A given to you? Matrix A given to you that 0, 2y, 1, and 2x, y minus 1, 2x minus y 1, and where x comma y belongs to R and x is not equal to y, correct? Then for which A transpose into A transpose into A is equal to 3 times of I is dash given to you. So for this type of questions, beta, what you have to do here is look at this here. A transpose into A given. So A transpose into A will do. What is A transpose? 0, 2x, 2x, 2y, y minus y, 1 minus 1, 1. This is A transpose into A. What is A? 0, 2y, 1, 2x, 2x, y minus y minus 1, 1 is equal to 3 into I. 1, 0, 0, 0, 1, 0, 0, 0, 1. Correct? So 3 into I can be written as simply can I write 3, 0, 0. So this is how we can write is equal to 3i. Correct? So let's multiply these two now. Multiply this, what you are going to get now? Check 0, 4x square and 4x square. So 4x square plus 4x square, you will be getting what? 8x square. And so 0 to xy minus 2xy. Okay, 0 into 1, 0, 0 minus 2x plus 2x. So 0 2xy minus 2xy. Again 4y square plus y square plus y square. So let me write directly, guys. Let me write directly. So 0 here, here also 0, and here 2y minus 0, 4y square plus y square plus y square, 6y square, and 0 here as in 0, 0, 1 plus 1 plus 1, 3. Correct? This is what we will be getting here after multiplying these two matrices. Okay. After multiplying these two matrices, I got this one. Very good. Now look at this here. If I compare, so if I compare the elements, 8x square is equal to 3, 6y square is equal to 3. So x square is equal to 3 by 8, x is equal to plus or minus square root of 3 by 8. So y square is equal to 1 by 2, y is equal to plus or minus square root of 1 by 2. Correct? This is what we got here, x and y values. So here the matrix given to you is, A is equal to something given to you, this one, and A transpose into A is equal to 3i given to you, and x comma y belongs to R, and x is not equal to y here. Very good. So for x is equal to root 3 by 8, and y value, look at it, 1 by root 2. One thing, x is equal to root 3 by 8, y value minus 1 by root 2. Correct? All right, this is one possibility. And x value minus root 3 by 8, y value 1 by root 2. For x value minus root 3 by 8, y value minus 1 by root 2. How many, look at it here? With 1x and 2 y values. With 1x with 2 y values. So how many matrices possible now? Tell me. Guys, how many matrices possible? Total 2 plus 2 matrix. Look at it here, from this 2 matrices, and from this 2 matrices. So 2 plus 2, total 4 matrices. Total possible here. Correct? Sir, how 2 matrices possible here? 1x value beta with 1x value, and this was one matrix. With this value, 1 matrix is possible. With this another matrix is possible. So 2 matrix. So with an x negative, y positive, 1 matrix. X negative, Y negative, one matrix. So total 2 matrices here. Is it clear, people? Any doubts? Guys, any doubts? Any doubts? Guys, any doubts? Are you here? People, any doubts?
No, sir.
Very simple, beta. This is a very simple question. Next. Now, if I go with option, check. Option D is correct here. Okay, good. So now we'll go for the next question. And today itself, I'll be starting with the determinants as well, beta. So let's finish, make it fast. So this question, if A is a symmetric matrix, and this question has been asked in 2019, yes. A is a symmetric matrix, B is a symmetric matrix, such that A plus B is equal to this, then AB is equal to dash. Very simple. A is a symmetric matrix, B is a skew symmetric matrix, such that A plus B is equal to that, then AB is equal to what? This is a very simple question. I'm expecting an answer very, very soon from you all. Okay, very simple question. Let me solve this. A is a symmetric, B is a skew symmetric. So look at the question. A is equal to symmetric matrix, which is nothing but A is equal to A transpose, and B is equal to skew symmetrics given. So which is nothing but B is equal to B transpose. Sorry, B is equal to minus B transpose. Or else you write B transpose is equal to minus B, correct? Any doubts here? Or if B is equal to minus B transpose, also fine. Prashant gave the answer. Wonderful, Prashant. Right answer, beta. Look at this. So first of all, he has given what he has given here. A plus B is equal to 2, 3, 5 minus 1 given to you. This is what given to you. Given A plus B is equal to this. So A is what here? What is A? A transpose. What is B here? Minus B transpose. Beta B value I'm substituting here, which has minus B transpose. So A transpose minus B transpose can be written as the same matrix. From this I wrote this, from this I wrote this, from this as it is I wrote. Correct? Good. But look at this here. A transpose is equal to what? A transpose is equal to what? As per the condition, A transpose is equal to A minus as it is. B transpose is equal to what? B transpose is equal to what?
Minus B.
Yes. So let's keep as it is. So minus b. So b transpose is equal to minus b. So a minus b is equal to what you got. So 2. First of all, we'll do one thing better. Let's not write like this. We'll do one thing very easy if you do like this. First of all, a plus b whole transpose is what beta? A transpose plus b transpose, can we write? Am I correct? So a plus b whole transpose. Let's do a plus b whole transpose. A plus b whole transpose is what? 2, 5, 3 minus 1. So A transpose is nothing but what? A. B transpose is nothing but what? B. So A minus B I got here. Am I correct? So look at this here. So let's not do this. Very simple. Now look at this. A plus B I got, A minus B I got. So let's add this elimination method. A plus A, 2A. Plus B minus B will be getting cancelled. Adding this matrix plus this matrix. So 2 plus 2, 4. 3 plus 5, 8. 5 plus 3, 8. Minus 1, minus 1, minus 2. Am I correct? Isn't it? So now A matrix is going to be what now? A matrix is equal to 4 by 2, 2, 8 by 2, 4, 8 by 2, 4, minus 2 by 2, minus 1. Correct? So this is what my A value is going to be. Then B value is what? B value is what? Substitute anywhere. Substitute here. So B value is what? A minus. So this minus this matrix. Which matrix? 2, 5 minus 2, 5. 3 minus 1. Correct? So 2 minus 2, 0. 4 minus 5 minus 1. 4 minus 3, 1. Minus 1 plus 1, 0. Correct? This is what my B matrix. Now he is asking us to find out the answer of A into B matrix. A matrix I got 2, 4, 4, 1. B matrix I got 0, minus 1, 1, 0. Okay. A matrix is what now? I got this. So A 2 into 0, 0, 0 plus 4. Minus 2 plus 4, 2. Minus 2 plus 4, right? Okay. So 0, 4 and minus 2 plus 4, yes. And 4 minus 1 here. And how much? Minus 4 minus 1. Guys, is it, did we write correctly? No. Beta, I wrote B matrix wrongly here. Look at this. Here it should be 0 beta. Okay. Yes. So 4 into 0, 0 minus 1 minus 4. So minus 4 here. Now 4 here minus 2 only. So yes. So minus 2. So AB value is this one. Which option is correct now? Option B is correct. Option B is correct. Any doubt, guys? Prashant, very good, Prashant. Any doubts? So far, any doubts, children? All these are previous year question, 2019 JEE question. Okay. Next, we will go with one more wonderful question. All these are determinate questions. This one, yes. Solve this question, everyone. Everyone solve this question. A matrix given to you, A into A transpose equal I3, then modulus of P is what? Make it fast. Let's see how many of you will solve this. Quick, make it fast. How, Adesha, how did you get it? Adesha, how?
Sir, it is given P magnitude, no, sir. Then
What is the Q value you got? Q value, Q square value.
1/4, sir.
so 1/4, sir.
Q value, no, not 1/4. What is the R square value? No. Can't
Sir,
be 1/4.
Q value 1/2, sir.
No, 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 no. P, no, 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 no. Q value, Q. I'll teach you. Look at this here. A matrix given to you that 0, 2, Q, R, P, Q. Here what? P, Q, minus P. All right. So A into A transpose is equal to I3. Then modulus of P is equal to dash. That is the question. Okay, wonderful. So A into A transpose. Let's do A into A transpose. 0, P, Q, P, 2, Q minus Q, R minus R into A transpose. What is A transpose? 0, P, 2, Q minus Q, R minus R is equal to I3. 0. I3 is nothing but 1, 0, 0, 0, 1, 0, 0, 0, 1. Correct? Very good. So let's solve directly multiply. Let me multiply. So 4, how much beta? 4Q square plus R square, 2Q square
Sir.
plus minus R square. Yes, beta. Minus 2.
Sir, but we have to find just for P value, no, sir. Why to find Q and R value, no, sir? Directly I got P value, sir.
Yes, no problem. We have to find out only P value, but until and unless finding P value, sorry, Q value and R value, I don't think so it is possible to find out P value directly. But let's check. 1 second. So let me write and compare. Then we can come to know what exactly. How can we solve very quickly? Okay, P square plus Q square plus R square. Next, P square. Guys, any plus minus any mistake, you just immediately tell me, guys. P square minus Q square minus R square. Next, P square 0. So minus 2Q square plus R square. And here P square minus Q square plus R square. And P square plus Q square plus R square is equal to what, beta? 1, 0, 0, 0, 1, 0, 0, 0, 1. Correct? So this is what we got. Now just compare. So 4Q square plus R square is equal to 1. I'm comparing A1 1 position. Check. This is equal to this. I'm comparing. Okay. And this is equal to this. And next, this is equal to, let me use another color. This is equal to this. Check. Understood? Okay. Now, how do you find out P value directly here, Adesha? Until and unless finding any one value, you can't find out P value easily, right? Am I correct? So here, 2Q square is equal to R square. R square value I got. Let us consider this equation number 1. So let us substitute here. 4Q square is equal to R square value. How much better? 2Q square. Substituting from the first equation, I'm writing this. Okay. So 6Q square is equal to 1. Then Q square is equal to 1/6. I got. Don't find out Q value. Let it be Q square. Why? Because I have to substitute here. Okay. Substitute there. Q square. Let us substitute here, beta. So let us consider this as second number equation. From the second number equation, 2 into 1/6 is equal to R square. Then R value is what, beta? R square is equal to what, beta? 1/3. R square 1/3 I got. So everything substitute here now. P square value we need to find out, right? Q value is Q square 1/6. 1/3 is equal to 1. P square is equal to 1 minus 1/6 minus 1/3.
Sir,
Yes.
you wrote that equation, no? P square plus Q square plus R square is equals to 1. You round it off with yellow color, sir. At the side of it only, P square minus Q square minus R square is equals to 0, no, sir?
Yes.
Sir, if we will add those two equations, we'll get the P value, no, sir?
No, beta, look at this here. You are saying, this one you are saying, this one is equal to 0. This one you're talking about?
Yes, sir.
Even you
Yes,
take
sir.
that, what is the answer? That is equal to 0. Now p square is equal to what? Q square plus r square, right? You can take like that as well. Instead of doing that, yes, absolutely no problem. But if yes, comparing and just look at it, you are saying that sir q square r square is equal to p square, so p square plus p square is equal to 1. So 2p square is equal to 1. So p square is equal to 1 by 2. P is equal to plus or minus square root of 1 by 2. So magnitude, if I take, so what is the magnitude? So magnitude of p is equal to 1 by root 2. This is also correct.
1
Absolutely.
by root 2.
Yes. Yes, even you take these two, you can do that, no problem. Absolutely right answer. You need to find out only p, need not to solve all this. Without solving this also, look at this and this also, you can do very easily. Correct? Anything is fine. Anything is fine. But whatever I solved, it is taking like, it takes 10 to 15 seconds extra if you solve somewhat fast. But if you go with this, you take like 10 to 15 seconds of time, somewhat less. All right. So p value is 1 by root 2. Option C is correct. Next. Everyone solve this. 2019 John. Everyone solve this question. Quick. Guys, time up. Look at this. The question given to you is p is equal to something given to you. 10031. What was that? 310 and next 931. Correct? And q is equal to qij given to you. B2 3 by 3 matrix. This is also 3 by 3. This is also 3 by 3 matrix given that such that q something given, right? Such that q minus 1 second, guys. So q minus p to the power of 5 is equal to I3. Okay. This is, then he is asking us to find q21 plus q31 divided by q32 is equal to dash. This is my question here. Here, first of all, very simple question. This is a very simple question, I would say. Okay. First of all, let's find out p to the power of 5. What is p square you got? P square value. Tell me, guys, you might have find out p square value, right? What is p square value? You can tell me p square value, guys. What you all are doing? What you guys all are doing? I'm asking. Without finding p square, how come it is possible to solve it up? P square value, I'm expecting these basic steps from your side. You can't make me to solve all these simple steps again and again. Is it clear? Okay, so P into P. So look at this, 1 here, 0, 0, 3 plus 3. Let's write like this, 1, 0, 9, 3 is 27, 3 plus 3 here, 1. This is P square value. Now P square, right? P cube is what? P square into P. P square is what? 1, 0, 0, 3 plus 3 and 27, 1. All right. So this is what P square into P. What is this P? 1. P, what was P? 1, 0, 0. 1, 0, 0, 3, 9, 1, 0, 3, 1. Guys, tell me the PQ value now. 1, 0, 0, 3 plus 3 plus 3, which means 9 you get. I mean 3 plus 3 plus 9 I'm writing. 1, 0, 9, 54, 3 plus 3 plus 3, 1. So P cube, I got this. Now P power of 5 is what? P cube one here what? 9, 54, 0, 1, 9, 0, 0, 1. This is P cube. P square, what is the P square? 1, 0, 0, 6, 1, 0, 27, 6, 1. Yes. So P to the power of 5 is going to be what now? 1, 0, 0, 15. You have to be very fast at calculations. 135 here. Yes, 135 only, right? Correct. 15, 1. This is P to the power of 5. Guys, multiplication of two matrices only I'm doing. Hope it is clear. Prashant given the answer. Very good, Prashant. So this is what I got. But given what he has given here, given that Q minus P to the power of 5 is equal to I3. What is Q? We don't know Q value, right? So I3 plus P to the power of 5. Q is equal to, what is I? So let's go with Q is equal to I. What is that I? I can be written as 1, 0, 0, 1, 0, 1, 0, 0, 0, 1 plus P to the power of 5. What is P to the power of 5? 1, 0, 0, 15, 1, 0, 1, 35, 15 and 1. Okay. So 2, 0, 0, 15, 2, 0, 135, 15 and 2. So this is Q I got. So he's asking for what? Q 21, Q 31, not 21, 21, Q 32. Now Q 21 is nothing but 21, 15 plus Q 31, 135. Q 32, third row, second column, 15. So 150 divided by 15 is equal to 10 is the answer. This is the final answer. Is it clear? So option A is correct. Any doubts, people? Children, any doubts?
No, sir.
Okay, very simple question it was, but bit calculation part you have to take care. Any doubts? Children, any doubts so far? See, I repeat the question if you have any doubts. Here, look at the question. This has been asked in 2019 beta. When? 2019. P matrix given to you, Q matrix given as Qij be two 3 by 3 matrices such that this condition given to you. Then we need to find out Q21 plus Q31 divided by Q32 is equal to what? So very simple here, matrices and determinant questions would be as innocent as possible. If you ask me, very simple. Everyone knows how to solve that. You all need to take care of here is calculation part. If you are good at calculations, if you are somewhat fast at calculations, I would say that there is no chance of making a mistake in this type of questions. See, whatever the questions, you just go through all the recordings, go through all the notes which I have given in the class. All the questions, there is a no chance of, there is a no complex point we have made. Every point is very simple, easily understandable. All these are JEE questions. Look at this, whatever the questions I have given you so far, all these are better previous year only. Previous year questions, 19, 20, 21. So now here P matrix, Q matrix given. I just look at this here. P to the power of 5, we just found. Why did we find out that? Because he has given the statement called Q minus P to the power of 5 is equal to I3. So I matrix I know, P to the power of 5 I can find out from the given condition. All right, from the given matrix I can find out P to the power of 5. I just substituted there. I just got, look at this here, Q matrix as I3 plus P to the power of 5. Q matrix is what? I is nothing but identity matrix plus P to the power of 5 I got. From that Q matrix I got. Look at this, I know that this is Q11, sorry, Q11. Q21 we need. Q21 is nothing but 15. Q31 is nothing but third row first column. This one. Q32 is nothing but third row second column, which is 15. Adding all this I got, and after simplification I got 10 answers. Very simple. So beta, this is enough for matrices. So I just try to cover all possible previous year questions. So I'll be sharing you worksheets. Now this is the time to go with determinants lesson. Shall we move forward? Shall we move forward? And I think one thing we left with matrices, that is elementary row operation. Let us discuss. So after this, I'll go with that. Elementary row operations is a simple thing only. If you know elementary row operations better, in a determinants lesson, you'll be using all these elementary row operations. Elementary operations of matrices. Elementary operations of matrices. Here, I'll teach you this in a very simplest manner. Very simplest manner. See, elementary operation is nothing but what? Elementary operation is nothing but what? First of all, let's talk about in how many ways elementary operations can be done. Elementary operations can be done in two ways, beta. You can do either by row wise or column wise. All right, either row wise or column wise. For row wise and column wise, you have three operations, beta. 3 properties, row wise, 3 properties, column wise. But you can do either row wise or column wise. So most of the times you'll be following row wise only. It does not mean that column wise you cannot do that. Column wise also you can apply, but let us stick to row wise, which is convenient. Guys, can you hear me?
Yes, sir.
Yes. See here, elementary row operations we left with. Elementary operations is nothing but beta. I'll tell you, this can be done in 2 ways, row wise and column wise. For doing row wise, we have 3 properties. For doing column wise, we have 3 properties. First of all, I'll not be going with column wise. Why? Because you can go with that, but my favorite my favorite thing is going with row wise is my favorite thing. So I'll go with row wise, and I'll teach you row wise only. And column wise also, you can make absolutely nothing wrong with that. I'm telling again and again. But I'll go with row wise. It makes me feel comfortable. Okay, first I told right 3 properties. Let me go with the first property. See beta, here if I take any matrix, first property I'm telling you 1 2 3 4. Let's say that A matrix I take. If A matrix is equal this one, here beta, first as per the first property, R1 can be interchanged as R2, R3 can be interchanged as R2, R1 can be interchanged as R3. Anything, any row can be interchanged as other row. Look at this, R1 can be interchanged as R2, R2 can be interchanged as R1, R3 can be interchanged as R2. Similarly, R2 can be interchanged as R3, and R1 can be R3, R3 can be R1. So let me tell you now, if I follow this one, what is the answer is going to be now? How the matrix is going to be now? R1 is going to be R2 and R2 going to be R1. What is the meaning of this beta? R1 implies R2 is nothing but R1 is changing R2, but I'm using not implies here, I'm using by implies. I'm using by implies, which is nothing but R1 goes as R2, R1 comes as sorry, R2 comes as R1. So now look at this here, 1, so 3, 4, 1, 2. Now R2 became as R1 here, R1 became as R2. Hope it is clear. That's the first property. Very simple. Very simple. Any row can be interchanged. Any two rows can be interchanged. They can be replaced their positions. Hope it is clear. That is a property number 1. Similarly, column as well. Look at this, column 1, column 2, right? Any columns can be interchanged. Any column can be interchanged. C1 can be interchanged as C2, C2 can be interchanged as C1. That is a property number 1 which you need to follow for. All right, beta? Yes. Now, second property, if A matrix, let me take another same matrix 3, 4, same matrix I took. But any multiple, any row and any column, I would say any element of row, any element of column can be multiplied with any scalar except 0. Look at this here, let me tell you. Here, A, you say like R1. I'm taking R1. R1 can be multiplied with any scalar, K times of R1. What is the meaning of this? R1 changing as K times of R1. So if I take like R1 3 times of R1, R1 changing as 3 times of R1, then what is the matrix is going to become now? So 3 times of R1, I said, beta, what is R1? This is my R1 here. This is my R2 here. So 3 times of R1. R1 only changing here. R2 will be same. R2 is going to be remain same. What is my R2? 3, 4 is R2. Don't disturb R2. Write R2 as it is. I'm changing R1. How I'm changing R1? 3 times of R1. So 3 times of 1, 3 times of 2. So what is the final matrix is going to be now? A matrix is going to be 3, 3, 6, 4. This is your matrix is going to be. Correct? Any doubts? Sir, why did you applied elementary row operation on row 1 only? Why can't you apply on row 2? Who said to not apply? You can apply absolutely. Nothing wrong with that. Look at this here. R2 can be interchanged as 10 times of R2. Sorry, R1. You say R2. Yes. R2 I'm changing, right? Yes. How? A is equal to the R2 only I'm changing here. Then R1 will be remain same. 1, 2. 10 times of R2. So 10 into 3, 30. 10 into 4, 40. This is how the matrix is going to be. Similarly, it follows with the column 1 as well. Column 1 can be interchanged as 10 times of column 1. Column 2 can be interchanged as minus 5 times of column 2. Any scalar, look at this here, K is scalar here. All right, beta. K can be that, you can multiply any element. You can multiply with any element. Any doubts?
No, sir.
If you have any doubts, you can ask me immediately so that we can move forward. Understood? So that should be non-zero, beta. K cannot be 0 here. Okay, you can multiply with any non-zero number. Any row element, any column element, you can multiply with any scalar except 0. Next. Second property done. Third property, if I take A matrix like this, 1, 2, 3, 4, let me take same matrix. Beta, third property says that if I'm applying elementary operation on R1, row 1, R1 can be interchanged as R1 plus 3 times of R2. You can write like this, and R2 can be interchanged as 3 times of R2 minus 5 times of R1. You can write like anything. You can add R1 plus R2 with multiplying with scalar. You look at this here, I multiplied with the scalar and subtracted from R1. You can add or subtract by multiplying with any scalar. That is a property number 3 says to you. So look at this now, how the matrix, if I apply this row operation, if I apply this elementary operation, what is the matrix is going to be now? R1 only changing here. R1 we are changing. So R2 is going to be remain same. How R1 changing? R1 plus 3 times of R1. R2. So R1 plus R1 is 1 here. 3 times of R2. 3 times of 3. R2 is what? 2 plus 3 times of 4. Correct? Isn't it? So A matrix is going to be 1 plus 9, 2 plus 12, 3, 4. So how matrix is going to be changed? 10, 3, 14, 4. Correct? This is how matrix is going to be changed. Similarly, look at this. You just solve this. R2 interchanging as 3 times of R2 minus 5 times of R1. You can do however you want, beta. You can do however you want. Absolutely nothing wrong with that. These are the basic properties which you have to stick for. Any doubts in 3 properties? Any doubts in three properties? Any doubts
No,
in three
sir.
properties? Guys, do you have any doubts?
No, sir.
You don't have any doubts. Sir, we learned elementary operations by row wise and column wise. Absolutely fine. But why do we use elementary row operations? Why do we use elementary operations? Why do we use that? What is the reason behind using elementary operations either by row wise, column wise? To find out E inverse of a matrix beta. Why do we use? We use elementary operations to find out the E inverse of a matrix. What is inverse of a matrix? Let's discuss. First of all, you should know what is invertible matrices. Invertible matrices. Invertible matrices. Invertible matrices is nothing but beta. If AB is equal to BA is equal to I, that is an invertible matrix. How? Look at this here. AB is equal to BA is equal to I. Now here I can say that if first suppose if I take this, now B is E inverse of A. If I take beta, look at this here. If I take AB is equal to I can say that A is E inverse of B. Very simple. Understood my point? AB is equal to I is nothing but A is inverse of B. How? A is equal to I by B. B goes like that, like that. I'll tell you now. E inverse of A. How do you denote this? Here B is E inverse of A and it is denoted by A inverse. How do you denote that? How do you denote that? A inverse. How do you denote this as? B inverse. Very simple. Correct? But you can say this as A is a inverse invertible matrix. How can you say this as? A can be said as A can be A can be said to A is said to be invertible matrix. Very simple. Is it clear? Is it clear? Invertible matrix is nothing but simple beta. AB is equal to BA is equal to I. Very, very simple. If BA is equal to I is nothing but here, if I take BA is equal to I, you can say B is what? Inverse of A matrix, denoted by like this. If AB is equal to I is nothing but A is inverse of B, denoted by like this. Any doubts? Any doubts?
No, sir.
Very simple beta. So let me go with the questions. I'll give you a couple of questions here. I told you that we'll be using these elementary row operations to find out what? To find out inverse of a matrix. Again, you will be getting inverse concept in a determinants lesson. I'll tell you the shortcut over there. Now, if at all I ask a question something like this, using elementary transformations or operations, elementary operations or transformations, transformations, find E inverse of a matrix is equal to 3. Okay, find the inverse of this matrix. How do you find out? But elementary operations, I said, I didn't mention you, I didn't specified you that you have to use row wise or column wise. You can use anything beta. Okay, you can use anything. Look at this here. First of all, let me tell you, by using elementary row wise operation. I'm using row wise, not column wise. Okay, how? But for using row wise, the condition is A is equal to IA. This is the condition you have to use for what? Row wise. For column wise,
A is equal to AI.
AI, artificial intelligence. You can remember like that. AI. This is the column wise condition. All right. A is equal to A. Let's write now. A matrix is what beta? 1, -1, 2, 3 given to you. I matrix is what beta? 1 0 0 1. Okay, and A matrix here. Okay, so this is what the sir, why don't you write again A matrix again as this one? If you write A matrix again over there, then how do you find out A inverse beta? We need to find out A inverse. Okay, let this A be as it is. This A I'm writing as for the given question, I matrix as I'm writing as identity matrix. Your ultimate job here is to do that. You have to make this matrix as beta identity matrix. How? 1 0 0 1. You have to bring this matrix as like as an identity matrix. The circled matrix should become as an identity matrix. Again and again I'm telling. For converting that as an identity matrix, I am applying elementary row operations. How? Here, how to make this matrix as an identity matrix? Look at this. First of all, let us focus on this and focus on this. This is I'm having one here, I'm having one there. Okay, this is 1. I need to make it as 1. Already it is 1, no problem. I need to make this as 1. I need to make this 2 as 0. I need to make this minus 1 as 0. How can we make that? First of all, let us focus on zeros and let's make these two positions as 0 0. Correct? How can you make them as 0? I'm interchanging R1 here. First of all, let us go with R1. R1 interchanging as how? 3 times of R1 plus R2 plus R2. Can I do like that?
Yes,
R1
sir.
interchanging as 3 times of R1 plus R2. How? I'm changing R1 only, not R2. R2 is going to be remain same, 2, 3. R1 interchanging as what? 3 times of 1 plus R2. R2 is 3. 2. So 3 times of minus 1 plus 3. Sir, why did you do like this? Why? Because beta, my ultimate job is to make these positions are 0. Now if I do this beta, look at this here. If I do this operation, this position becomes 0. How? Look at this. 3 plus 2 5 2 3 minus 3 0 3. This becomes 0. Perfect. I made this position as 0. Now let's make this position as 0. How can you make that as 0? How can you make that position as 0? That is in R2 beta. I need to change R2 now. R2 changes as what? 2 times of R2 minus 2 times of R1. Sorry, R2 minus 2 times of R1. R2 minus 2 times of R1. Correct? R1 is going to remain same 1 minus 1. R2 how? 2 minus 2 0. 3 minus 3 plus 2 5. Am I correct? My goodness, I didn't do this right hand side. Right hand side also we have to do beta. Okay, here R is equal to R2 is same, right? 0 1 into A as it is. How? 3 times of R1. 3 plus 0. 3 plus 1. Correct? Is it clear now?
Yes, sir.
Okay. Now here I made this position 0. Very good. Now we need to make this position as 0. Which one? This making this 2 as 0. How? By applying
Sir,
this. Yes.
can we take R2 is equals to 5R2 minus 2R1?
Absolutely nothing wrong with that. You can go ahead. Anything. Our ultimate job is what? See, beta, there is no such condition that you have to use this only. You have to use this only. You can do anything. You can multiply with any scalar, right? Told, right? Our ultimate job is what? Making that as 0. You can make anyhow. As per your wish, you can make anyhow. That is not discussable over there. That is not
Yes, sir.
judgeable. Your job is to make this position and this position 0. You make however you want. You apply whatever the elementary operation comes to your mind, but it should be 0. It should be 0. Okay. So now look at this here. R2 changing as R2 minus 2 R1, right? R2 minus 2 R1. R2. Yes. Look at this here. R2 changing. So we have to apply on this beta. We have to apply here. Okay. R2. So R1 is going to be similar, remain same 5 0. And here also R1 is going to be same into A. R2 changing as what? R2 minus. No, actually we have to apply on this, right? Then whatever you said, that is correct beta. 5 times of R2 minus 2 times of R1. 2 times of R1. Yes. 5 times of R2 is nothing but 2, 5 to 10, 10 minus 10, 0. Correct? So 3 times of 5. 15 minus 0, 15. Correct? Understood my point? And here R2 is what? 0 minus 6. And 1 into 5. 5 minus 2, 3. Correct? This is what I got, beta. Any doubt
Yes,
till
sir.
this? Till this, any doubts?
No, sir.
Look at this. This position becomes 0. When? If you apply this elementary operation. Guys, are you able to see here? If you write this properly, calculations are very easy. Everyone can make calculations. Very good. Now these two positions become 0, beta. Now making these elements as 0. Sorry, making that elements as 1. How can you make them as 1? R1 can be divided with what? By 5. 1 by 5 into R1 and R2.
1 by 15 into R2.
1 by 15 into R2. Very simple. Look at this. That becomes 1, 0, 0, 1 is equal to 1 by 5, right? So 3 by 5, 1 by 5 and minus 2 by 5, 1 by 5 into R into A. Now look at this here. This can be written as I. Now I changed this matrix as I row, isn't it? This as it is, I'm writing into A. So I by A is equal to this matrix as it is, you guys write. Now I by A, right? I by A can be written as I into A inverse is equal to same matrix. I into A inverse is what? A inverse only. I into something is beta. I into something is always something only. So A inverse is same matrix. Whatever the matrix you got there, you write the same answer. 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. This is A inverse answer. Hope it is clear. Hope it is clear. Any doubts, beta? Any doubts? Guys, any doubts?
No, sir.
Yes. Please go and watch the recording again if you have any doubts and understand why we are doing that. I told making the given matrix as identity matrix. That is our ultimate aim. For that, I'm applying elementary row operations. It does not mean that you can't apply elementary column operations. Still, you can apply, but I go with row operations, which is my favorite. You just choose which is your favorite one and stick to that. Go ahead. Thank you. Neha Kiran. Hi, Neha. How are you? Neha, are you here? Neha ji, are you here or not? She is not here.
Sir.
Why are you late? I don't understand. Why are you
Sir,
late?
my network.
Sorry.
I had network issues, sir.
Please make sure that you are attending all the classes. But if you don't attend the classes, if you attend in between, you will miss the flow. You will not understand anything what I'm teaching in the class if you join in the middle. Okay. Please go and watch the recordings and come up to the next class with the doubts. Okay. Thank you.
Yes, sir.
Thank you, beta. Goodbye.